Okay, it's still Sunday evening, and I've decided to throw yet another video together to help us get through this uh, week six. Uh, the week six tailgate is going to be a little bit different. Not going to go by the usual rules. You won't have three posts. You'll be able to discuss back and forth, but you're going to answer one question, and it's going to be a problem, a calculation related to the topic of the tailgate, which is order of operations. And order of operation is when you have these large, well, they don't have to be an equation, they can just be a problem. And the problem is to determine the group index for a certain soil sample. And to do that requires some math. So I have a sample here, and it will be close to what the problem is for you. And by the way, you'll find the problem in the tailgate directly after the first video. The video you're looking at right this minute will be the second video. So I'm going to go through one of these problems, and you'll have some givens. You'll be given you'll need and be given, and we will I'll know by looking at the numbers where they are in I want to keep calling it a formula, but it's not. It's a problem. We'll tell you where that number comes from, but they are available uh, during your classification of the soil. So, uh, with that, let's just start up here. I would have put all of these. This is the problem. Uh, to find the group index, you have to know this figure. I know what that is. That is the percent passing the number 200 sieve. I know what it is because of where it is in this problem. In this case, it's 33%. That tells me I've got a pretty coarse soil. The 35, the 35 is a constant, and that's what I would call it, a constant. It's always going to be the percent passing the number 200 sieve minus 35. And then that's going to be multiplied, whatever that number is, and I can show you right quick what it's going to be right there, minus 2. But we're going to keep going down. And we keep things just as they are until we get down to the bottom. So after the 33% passing is entered, the 35 is constant, and this 0.2 plus 0.005 is another constant. It'll always be that. And the next figure will be your liquid limit minus 40. The 40 will always be 40 in all of these problems. The liquid limit, which I know goes right here because it's in the formula, not formula, the problem is 46. So this is in parentheses, as you can see. Moving on across, that is added to more constants. This 0.01. Don't disregard this. This is a note I made for a former class, but this is accurate. I had a 0.001 before, and it's not. It's 0.01. So that will be multiplied times the percent passing the number 200 sieve minus 15 times the plasticity index will go right here, in this case 17, and that's minus 10. So you have this constant times the percent passing the number 200 sieve minus this constant 15 times the plasticity index, which will vary. In this case, it's 17 minus 10, which will stay the same. Now, go back over here and let's start getting rid of things. This is PEMDAS, so that's getting rid of uh, the bracket is like parentheses within parentheses. So uh, let's just follow what I did right here. In this case, you have this will stay the same, so you bring it down, right? This will stay the same, so you bring it down. There's nothing we can do to it yet. This, however, is in parentheses, and so that's the first letter in PEMDAS, so we can go ahead and subtract the uh, oh gosh, yeah, okay. The 46 is minus 40. Oh, that's the liquid limit. I'm sorry. The 46 is your liquid limit minus 40. Now these will be in plain sight and given this 46. I'm just having to look at two different things here. So you got uh, the this is, we're just going left to right. We got the liquid limit of 46 minus 40. We're going across here the percent passing the number 200 minus 15, and the plasticity index minus 10. Now we're going to drop ones. So the 33, get rid of parentheses here. The 33 minus 35 becomes minus 2 when I drop down. I can do that now. So I'm going to keep the 0.2 plus 0.005 times 46 minus 40. I'm going to keep it in brackets for now. Plus 0.01 times the percent passing 200 minus the constant of 15 times the plasticity index, 17 in this case, minus 10. So let's go one more time where we go all the way across and we don't do anything. That's probably me being repetitious, but but I didn't. I just dropped down. Everything I carried across stayed the same. This time when I dropped down, you will notice when I got to these parentheses, I got rid of them. So the 46 minus 40 became 6, and that changed that. Now, I'm still leaving the plus 0.01 times the percent passing 200, which is 33 in our case, minus the constant of 15 times the plasticity index of 17 minus 10. Okay, let's drop again. And this time I took, it looks like I took this, I got rid of these parentheses right here. And what I did was I subtracted the liquid limit minus that constant of 40. That gives me 6. And we had parentheses here, and I put a little X so I'll know. I've got to take this calculation, 0.2 plus 0.005 equals point, what have I got there? 0.2. You can get rid of this. This is way insignificant. That's 5,000. So we've got 0.2 and we're going to stay at 0.2. But we changed to 6 here, so when we drop, we took this 0.2. Let me double check. We took that 0.2 and how did I get that? Hold on. We should have 1.2 here. Where did I get the... Maybe I didn't do it like that. Hold on just a minute. 2 point, that would be 0.205 times 6. Maybe I'm getting ahead of myself. Just give me a second. 0.205 times 6 equals... I still get the same thing. I think this is a mistake right here. I think it's a mistake right here. I'll have to go, I'm going to leave it the same because I've worked this 2 or 3 times. I don't know how I'm coming up with this. It should, I thought I was going to come up with something like 0.23 here. Somewhere 0.2 plus, let me add that up right quick. Sorry about that. I already worked through this once. Believe it or not. 0.2 plus 0.005 equals, that's 0.205. And I'm not getting what I want. I'm not getting 0.3 times 6. I'm getting 1.23 right here. Let's see what that would do. This is all kind of 0.2 plus 0.03 is 0.23. So I'm going to feel like I'm not catching it yet. So let's go ahead with, I'll have to come back and look at that. But this is the number I'm wanting right here, because it goes all the way down to here. I don't know. I don't have an explanation right now. But this side stays the same. And by the way, everything on this side of the plus is called a partial group, and that will be used when we get into more fines. Then we have much more clay material. But these figures I've done, I know we're good here. I don't have an explanation why that's not right, unless I copied something down wrong. And I don't want to sit here all night trying to figure that out. So when I take 0.2 and 0.02 and drop down, I get 0.23 times 2. Those are in parentheses, brackets, and I'm taking them out of brackets here by doing this. I don't have an answer for that 03. I think I wrote it down wrong. I just don't have an answer right now. It should have been different. It should have been different. So anyway, so we get here and we have minus 2 times 0.23. These guys are staying, but notice this right here has changed because I've gotten rid of these parentheses. Now it's 33 minus 15, and that's 18. So we got rid of those parentheses, we're rid of the brackets, we're down to the 2 times 0.23 plus the same 0.01 times this in parentheses, remove the parentheses, it's 18, and I've still left the parentheses here, so that would be times 17 minus 10, but we're not there yet. Drop down once more, and we keep the same here, plus the 0.01 times 18, now times 17. So that becomes 0.01 times 18 equals 0.18 times, I'm sorry, 0.01 times 18 equals, hold on, equals 0.18. So we get that when you take 0.18, this would be 7. When you take, and I'm getting rid of the parentheses right here, leave 7. If you take 0.18 times 7, what do you get? We get 1.26. That's the answer. So this times 7 is 1.26, and you bring it down with the 1.46 is added to still 1.26, 0.46, because see, we multiplied 2, even though it's a negative, we multiplied 2 times 0.23, and we're bringing these down, got the 0.46, bringing this down, so we got 1.8, we got 1.6, and we got a minus 4.46. So if you take 1.6, let's see, 1.26 minus 0.46 equals, so we come down to 0.8, and our group index is 0.1. Now here, I really, I don't know what, I don't have that answer yet, but I do know that I've worked it 2 or 3 times, and it needed to be 2 plus that 2. It just needed to be 0.23 all the way down, and I'm not sure where I messed up somewhere here. That right there should have been no, that I didn't add it right. When I take 0.2 plus 0.03, I get 0.23, and that's what I want. I don't know why I got there. That's where I got the 0.23, and that's what I want. For some reason, my explanation was wrong, or I just ended up right. But I don't know. I don't have an explanation because I got to where I needed to be, 0.23, to come up with this 0.46, which I needed, and I got this 126 over here. So you round up on these things, and if it's this is 0.8, so we would classify it as a group 1, whatever A1, A2, A3, it would be group 1, so we'd have a really good soil here. It may just be me. I've done this problem 2 or 3 times, and I'm not sure why I don't have what I thought I would have. I just think it's just I'm making a mistake. So I don't, the answer's right. That's what I've always got. But anyway, I'm not going to grade you harshly on this for sure. This will be in the tailgate, and you don't have to say anything, but you can talk to each other in that tailgate for week 6, and you can also, if I get a chance, I'll jump in there and see where you're struggling and make it. Maybe I can help, although I don't know how well I helped with this little video, but it's something. It's a nugget, and we'll stop there and keep trucking. Talk to you guys later.